Today we're going to start chapter 7. We're going to cover section 1. You will have a quiz on 7.1 and 7.2 next Monday. So I'll be adding that to Canvas. So next Monday will be your first quiz of the fourth quarter. So we already had our first test. I did move the date of the test, even though we already took it. I needed to move it so it had a fourth quarter testing date. So I moved it so it looked like you were having a test today. I'm sorry if I panicked anybody, but we already took it. Everybody was here when we took it, so that was excellent. So then your first quiz of the fourth quarter will be next Monday. So again, we're going to be using the fundamental identities. We've already seen them. So the first ones are our reciprocal identities. So you should already recognize that the reciprocal of sine is cosecant. The reciprocal of secant is cosine. The reciprocal of tangent is going to be cotangent. So what we're going to be doing here in this lesson is we're going to be using these identities, whether this reciprocal, whether the Pythagorean identities, they're coming back, or the quotient identities, which are these. It doesn't have a name here, but the tangent and the cotangent. And we really didn't use the quotient identities, but we're going to be using these now. So we'll be using the reciprocal, the quotient, and the Pythagorean. Now, in your book, it does talk about the even-odd identities and the cofunction identities. We will not cover these in this course. You're going to cover that later on in your pre-algebra course. We're going to focus just on the reciprocal, the quotient, and the Pythagorean. Now, remember that when you're writing these, you need to include the variable here. If it's x, it's just representing the angle. Now, what you're going to see in WebAssign tonight is they tend to switch that variable up. So we've also seen where we used theta. So cosine of theta. This is, again, just a variable. They're using other Greek letters in the WebAssign. So whatever variable, whether it's a Greek letter or a regular letter, follows any of these trig words, it's just representing the angle. So on some of the WebAssign homework tonight, instead of theta, they use beta. Or they might, I forget what other ones you're going to see. They might change the variable and they might use the letter y instead of x. But just know that these are all just variables that are standing in for the angle. Now, also one other thing you should be able to do, and I know we talked about this before, is to take these Pythagorean identities and rearrange them to any form. So, for example, if we take the first one, the sine squared x plus cosine squared x equals 1, be able to solve this for either sine or cosine. So, for example, I could subtract the cosine x from both sides, squared x, and then I get what sine squared x equals, which is going to be 1 minus cosine squared x. I can do the same thing and solve it for cosine. So just be able to recognize any forms of these Pythagorean identities, and then we're going to be doing substitution with them. So if I wanted to solve it for cosine, you would do the same thing just to show you, and you can do this with the other two as well. So again, set this. If I wanted to get cosine by itself, I would subtract the sine squared x from both sides, and then I could see that cosine squared x is equal to 1 minus sine squared x. Either way. So let's go ahead and let's see how we're going to be using these. So our goal here is to simplify. And when we're going to be simplifying, we're going to be using substitution, and we'll be substituting either the reciprocal, the quotient, or the Pythagorean identities to simplify our expressions. We're also going to be using our Algebra 1 skills. We'll be factoring. You could use something that's similar to what you did in 4th grade with fractions, where we're going to simplify diagonally. It's sort of like even dimensional analysis. So for example, if, remember back in 4th grade, when you had a fraction that looked like this, and I said to multiply this, and it was easier to simplify before you multiplied, this is sort of what we're going to be doing today. But instead of with numbers, it's going to be with the trig functions. So here I could simplify this and make this a 1, make this a 5, make this a 1, make this a 3, and then you multiply what's left, and it just turns into 3/5. Now, remember, when you do this cross simplification, it doesn't make it become a 0, it becomes a 1. So the same thing when I'm doing it with the trig. If I had sine x over cosine x, and I wanted to multiply this by its reciprocal, notice this would simplify because they're the same, and it becomes 1s, and then this would simplify and become 1, and this would be 1 over 1, which equals 1. So this is going to sort of be like the general idea of what we're doing here. So let's try some examples. So again, one thing to remember, that whenever you see a square in the problem, that could be a clue that you're going to be using a Pythagorean identity. The Pythagorean identities all have squares with them. So for this very first one, again, I'm going to use my Algebra 1 skills. I'm going to use factoring on this one, and I'm going to factor out a greatest common factor of sine x. So what I'm going to do is divide both of these by sine x. So I put the GCF on the outside, and then after I divide, this becomes a 1. So then now I'm left with cosine squared x minus 1. And if you remember your Pythagorean identity that I just rearranged for you, remember the sine squared x plus cosine squared x equals 1. If I solve this for sine by subtracting cosine squared x, I get 1 minus cosine squared x. This is what I'm going to substitute. Notice that's what's here. So I'm going to replace and put in its place sine squared x. And then I still had that GCF outside. And now, what I need to do here, though, is this is backwards. So really what's going in here is a negative sine squared x. And then when I multiply it, it becomes negative sine cubed x is the final answer. So your goal here is to try to simplify it down to a single term, and a single term that doesn't have a fraction. So majority of the ones we're going to do, except for towards the end, they'll be able to simplify to one term. Sometimes you may end up having to leave an addition or subtraction sign. Let's try the next one. I'm also going to factor out a greatest common factor first. Notice they both have in common the cosecant x. So that's going to be my GCF. So I'm going to divide both of them by cosecant of x, put the GCF on the outside, and now I'm going to put what remains after I divide. And just like before, same thing. I'm going to rearrange this, which I already did, and again, it's backwards, so this is a negative sine squared x. And next, I'm going to use my reciprocal identity. And the reciprocal of cosecant is sine. So now I'm going to turn this into its reciprocal, which is 1 over sine x. And now I'm going to multiply it by the negative sine squared x. This will simplify diagonally. I can change this to a 1. And just get rid of the exponent here, make it a 1 now. And now my final answer here is negative sine x. The next one, I'm going to be using my reciprocal and my quotient identities to simplify number 3. So I'm going to replace secant with its reciprocal, which is going to be 1 over cosine of theta. Notice the variable switched now. Before it was an x, now it's a Greek letter. It's still a variable and it's theta. Cotangent, I'm going to use its quotient identity. And the quotient identity that is equivalent to cotangent is going to be cosine theta over sine theta. And then sine theta, I'm going to leave alone. Now I'm going to look for things to simplify diagonally. Notice here, the cosine thetas cancel. They become 1s. They don't disappear because cosine theta divided by cosine theta is 1. And then I can simplify the sine theta with the sine theta. So then this becomes a 1. So now I'm left with 1 over 1. So this final simplified answer is just 1. For number 4, we're going to be using a Pythagorean identity and a quotient identity. So for the cotangent squared, I'm going to use a quotient identity. I'm going to change cotangent squared x into cosine squared x over sine squared x. And then what's in the parentheses, I'm going to use a Pythagorean identity. We memorize that tan squared x plus 1 is equal to secant squared x. So I'm going to do a substitution. I'm going to take this out and replace it with secant squared x. And now what I can do is turn this into its reciprocal, which is going to be 1 over cosine squared. And I still have the red. And now I'm multiplying these, but before I multiply, I'm going to simplify diagonally. The cosine squared x's become 1s. And now I'm left with 1 over sine squared x. I don't want to leave it a fraction, so I'm going to turn it into its reciprocal, which is cosecant. So cosecant squared x is the final answer here. You need to memorize that first slide. You need to memorize the reciprocal identities, the quotient, and the Pythagorean identities. Now, instructions change. Now they say simplify by factoring. So when I first look at this one, again, if it's easier for you to think of this, get rid of the trig word first. Move the exponent to the x. First, think of it as factoring the difference of two squares, x squared minus 1. Remember, this turns into x plus 1, x minus 1. Then all you have to do is put back in the word. Put back in secant in front of that x. So this will actually factor into secant of x plus 1 and secant of x minus 1. Remember, the order when you factor the difference of two squares doesn't matter. If you prefer to put the minus 1 first and then the plus 1 second, either answer here is acceptable. Then number 6. This is actually a trinomial. Now, remember, we need to get this into standard form. It already is for us. So again, if you want to think about factoring this without the word tangent in there first, again, the exponent will go back onto the x. So what we're really factoring here is 4x squared plus x minus 3. Now, this is small enough where we could probably guess and test. However, if you don't like guessing and testing, then you could also do factor by grouping. But if I guess and test here, the factors of 4 are either 1 times 4 or 2 times 2. So it's actually going to factor into 4 and 1. So if I put a 4x here and a 1x here, and then the factors of 3 are 1 and 3, but the 3 is negative. Now, if you're going to guess and test, you need to FOIL this, and you need to double check that it works. So if I quick FOIL this, 4x minus 3x minus 3, it does go back to the original. So I did factor it correctly. Then what you'll do is squeeze in or add in the word tangent in here in front of the x. So then this factored form would be 4 tangent x minus 3 and tangent x plus 1. Again, the order doesn't matter. Now, you could also factor this by grouping. Would have factored this by grouping. So the 4x squared, if you didn't like the guess and test, you would have multiplied the beginning and the end. So two numbers that multiply to give you negative 12x squared, but who add to give you the 1x in the middle. And those two numbers would have been negative 3 and positive 4. And then you would have factored by grouping. You would have left the first term the same, replaced the middle with the two factors you just found, and then rewrite the last term, and then make your groups here. GCF of the first group would have been x, and it would have been 4x minus 3 left. GCF of the pink group would have been 1. And then put the two GCFs together, x plus 1, and then what you got when you divided. Notice it was the same answer that I got when I guessed and tested. So if it says factor, you're going to end up with some binomials here. Let's try the next one. Difference of two squares again. So again, if you want to think of this as getting rid of the word cosine, put the power on the x. What we're really factoring is this. So this would factor into 1 minus x and 1 plus x. And again, put back in the word cosine in front of the word x. So then it would become 1 minus cosine x and 1 plus cosine x. The next one again is a trinomial. Now this is a typo. This should be a C here. So it's cosecant squared x. So again, if you want to think of this as 2x squared minus 7x plus 6, you can either, again, guess and test. Again, it's small enough where you could probably guess and test. Factors of 2 are just going to be 2 and 1. And then factors of 6 are either 1 and 6 or 3 and 2. And it's actually going to be negative 3 and positive and negative 2. Because in order to get a positive 6, my signs need to be the same. And again, always FOIL to check. Again, now squeeze back in the word cosecant. Right in between the 2 and the x. So this final answer would be 2 cosecant x minus 3 and cosecant x minus 2. Notice on all of these, all of the words, the trig functions here were the same. Number 1, it was just a secant. Number 6, it had tangent both times. And then number 7, it was cosine. And then 8 had cosecant for both. Now, on number 9, notice we got two different words here. So what I need to use here is a Pythagorean identity and do a substitution first so I can make both of the words the same. So what I'm going to be doing here is I'm going to be using the Pythagorean identity for this one. So I'm going to be doing 1 plus, this is what I'm using, 1 plus cotangent squared x equals cosecant squared x. So I'm going to replace this with this. So now it becomes 1 plus cotangent squared x minus cotangent x. I'm just rewriting the rest of the problem. Now I need to combine my like terms and get this into standard form. So I'm going to combine these two. So then I'm left with cotangent squared x minus cotangent x minus 2. Again, if you want to think of this without the word cotangent, what we're factoring here is going to be x squared minus x minus 2. Nice, easy trinomial to factor. Factors of -2 that give you -1 are going to be x minus 2 and x plus 1. Add back in the word cotangent in front of x, and factored will become cotangent x minus 2, cotangent x plus 1, or you could flip it and you could have said cotangent x plus 1 first, and then cotangent x minus 2. Again, the order of the binomial doesn't matter. I'm going to do the same thing on number 10. Notice the words are not the same. So in number 10, I need to either get them both to be secants or both to be tangents. So again, I'm going to use a Pythagorean identity, and I'm going to replace the secant squared x with a Pythagorean identity. So the Pythagorean identity I'm going to use is going to be tangent squared x plus 1 equals secant squared x. So I'm going to replace and put in tangent squared x plus 1. So this becomes tangent squared x plus 1 plus 3 tangent x plus 1. I need to combine these like terms and get it in standard form. So tangent squared x plus 3 tangent x plus 2. So again, if you want to get rid of the word tangent, what we're factoring here is x squared plus 3x plus 2. Those factors of 2 that will give you 3 are going to be 2 times 1. And again, put back in the word tangent. And again, the order of the binomials doesn't matter. So final answer, tangent x plus 2 times tangent x plus 1. So now instructions have changed. They're back to simplify. So again, I'm using my algebra skills. I'm going to be using my identities and see what we can do here. So what I'm going to do is I'm going to be using a quotient identity for cotangent. So I'm going to take out cotangent and replace it with its quotient identity. So sine x will stay. Replace cotangent with its quotient identity, which is cosine x over sine x. And then I'm going to leave the cosine x the same. Now I'm going to multiply. So now this one's a little different. So I'm going to multiply this right here. And this becomes sine x plus cosine squared x over sine x. Now, this is addition. It's not being multiplied, so I can't just cancel the sine x's. I need to find a common denominator. So again, fraction work from 4th grade. My common denominator is going to be sine x. So if you wanted to put a 1 here. So this is the only fraction that needs it. Remember, whatever you multiply to make the denominator become, you got to do to the numerator. So now this ends up being, once I multiply this, it becomes sine squared x over sine x plus cosine squared x over sine x. Now that I have a common denominator, I can add the numerator. So the new numerator, I'm going to add, and it becomes sine squared x plus cosine squared x. Now I just have the one denominator. Remember, we memorize a Pythagorean identity that sine squared x plus cosine squared x equals 1. So now I'm going to do a substitution, and I'm going to replace this with a 1 because that's what it equals. So now I have 1 over sine x. And again, I don't want to leave it a fraction, so I'm going to turn it into its reciprocal, which is cosecant. And that's your final simplified answer. So on this one, we used quotient identities. We did multiplication. We found least common denominator so we could add the fractions. And then we also used a reciprocal identity. So lots of different things, as well as a Pythagorean. So we used everything. Let's try number 12. I'm going to use my quotient identity again for cotangent. So I'm going to also use a reciprocal identity for cosecant. So I'm going to turn this into its reciprocal, which is 1 over sine x minus cosine x I'm going to leave. And then the cotangent quotient is cosine x over sine x. I'm going to multiply this. So I have this one the same still. This becomes cosine squared x over sine x. This one I already have a common denominator. It's sine x. So I can just add the numerator. So it becomes 1 minus cosine squared x over sine x. Now, if you remember this Pythagorean identity, sine squared x plus cosine squared x equals 1, if I rearrange it and solve it for sine by subtracting cosine squared x, sine squared x is equal to 1 minus cosine squared x, and that's what I'm going to substitute into my equation. I've taken this out, and I'm going to replace it with sine squared x. So sine squared x over sine x, and now I can simplify my fraction. The square goes away, and this becomes a 1. So then this becomes sine x as the final answer. So for this one, I'm going to start out because I can't really switch anything. Usually the easiest thing to do is try to get everything into sines and cosines. So they're already there. So what I'm going to do now is I'm going to find a common denominator. And my common denominator is actually going to be both of these together. So my LCD is going to be 1 plus cosine x times sine x for both. Let me go ahead and set this up. And then I'm going to figure out what each one is missing. Actually, let me do this in purple. Okay, so the first fraction is missing the sine x from the denominator, and whatever you do to the bottom, do to the top. So now this new numerator is going to be sine x times the sine x that's already there. And then the other fraction, this one was missing the 1 plus cosine x. So this will be cosine that was there, and then the 1 plus cosine x. So what I need to do is multiply and distribute. So for the first fraction, when I multiply these two, this just becomes sine squared x. And it still has the same denominator. And then this other one I need to distribute. So this becomes cosine x plus cosine squared x. And it still has the same denominator as the other fraction. Now that I have a common denominator and I've distributed, now I can combine my like terms. Now I'm actually going to apply the commutative property, and I'm going to switch these two terms. So when I go to write this, I have sine squared x. I'm going to flip and put the cosine squared x and then the cosine x. And then it's all over the same denominator. And the reason why I switched it was so that these two guys were side by side. Because again, remember, this is a Pythagorean identity. And I can replace that with a 1. Because if you remember up here at the top, I think right here, I'm substituting this for what it equals, which is 1. So now I have 1 plus cosine x over 1 plus cosine x times sine x. And again, since this is being multiplied, I can simplify this. I can cancel. This becomes a 1. This becomes a 1. And now I'm left with 1 over sine x. And again, I don't want to leave it a fraction, so I'm going to use my reciprocal identity. And then this just turns into cosecant x. So my common denominator is actually going to be both. So it's going to be this and this. So I'm going to write 1 plus sine x times 1 minus sine x. And that's going to be the bottom of the fraction for both. So the first fraction is missing the 1 minus. So whatever you're going to multiply to the bottom, do to the top. So 1 times anything is just itself. So this will just become 1 minus sine x on the top. Same thing over here. This one's missing the 1 plus sine x. And again, 1 times anything is just itself, so 1 plus sine x. Now that I have a common denominator, I can add my numerator. So when I add the top, this is 1 plus 1, and it's 2. But then this negative sine x plus sine x, it's just gone. And then I still have the common denominator. And now what I'm going to do is multiply it, because this is actually the factored form of the difference of two squares. So once I FOIL the bottom, it actually turns into 1 minus sine squared x, which again, I can use my Pythagorean identity that 1 minus sine squared x is equal to cosine squared x. And then now I can turn this into its reciprocal and flip it. So this becomes 2 secant squared x. Because remember, secant squared x is equal to 1 over cosine squared x. So I used a reciprocal identity here. So final answer is that, 2 more examples. We're going to learn how to use the conjugate. So we saw conjugates with radicals and imaginaries. Now we're going to see it here with these trig functions. The only time you really want to multiply something by its conjugate is if it's going to turn into a Pythagorean identity that you can use. So let's go ahead and take a look. Now this one's already set for us. Let's say this was the problem, just this, and they said to simplify it. So what we're essentially doing here is multiplying this fraction by its conjugate. So it's the same trig function, but it's a different sign. So for the top, 1 times anything is just itself. So what we're getting here is, for the numerator, 1 minus sine x. But for the denominator, we got to FOIL this. But remember, when you multiply something by its conjugate, all you really need to do is first and last. But if you forget, do the whole FOIL. So once I do this, first is 1 times 1, and then positive sine x times negative sine x is negative sine squared x. Now, the denominator is an identity. I can't just cancel this like this because this is attached. So what I'm going to do instead is turn the denominator in, and I'm going to use its Pythagorean identity and change it into cosine squared x. And then I still have the 1 over sine x. Now, this one's a little different. What I'm actually going to do here is pull this apart, sort of work backwards of if I were to add these. So I'm actually going to split cosine squared into cosine times cosine. And then it's 1 minus sine x. So then I can pull this apart and give each one its own denominator. So I'm going to actually turn this into 1 over cosine x minus sine x over cosine x. So I split apart this. I sort of factored it. So then now I can use my reciprocal identity here, turn this into secant, actually, this is going to be its own. This is going to be squared, squared. So then this becomes squared, squared. So then now what I have here is its reciprocal, secant squared x, and then minus, and then I'm going to go ahead and split this apart now, and this will become sine x over cosine x times 1 over cosine x. And then I'm going to use a reciprocal and a quotient identity. This I can make it into tangent x. This is a reciprocal. I can make it secant x. And then I have the purple one. Now this one actually has a subtraction sign in it, and this is as simple as it can get. Same thing's going to happen on the other one with the conjugate. What I did was I pulled this apart. I actually just gave each one its own common denominator. So this was the common denominator. I should have left it as cosine squared x. And then I just gave each one and I pulled it apart. So I sort of undid, I worked backwards of finding a common denominator, so to speak. All right, next one. This is where they didn't give us the conjugate, but in order to simplify it, I have to put in that I'm multiplying by a conjugate. So I'm going to multiply this one by its conjugate. I can actually do this 2 ways. I'm going to first show you, since we just did a conjugate, I'm going to show you that way first. So the conjugate would be 1 plus sine x. So again, I'm going to need to distribute, or let me just do this, cosine squared x times 1 plus sine x over, and then this just becomes first and last. And then what I can do again is replace this with its Pythagorean identity. So then I get cosine squared x times 1 plus sine x over, replace it with its identity, which is cosine squared x. This cancels, and then I'm just left with 1 plus sine x as the simplified answer. The other way that you could also have done this is if I take the original, and instead of using the conjugate, I'm going to replace this using a Pythagorean identity and make this 1 minus sine squared x. And then what I can do here is I can factor it. So this numerator is the difference of two squares. So I can factor this into 1 minus sine x times 1 plus sine x over the 1 minus sine x. And then these cancel. And then again, same answer that I got when I did it using the conjugate. So again, sometimes there's multiple ways to simplify these. But again, I would only multiply something by its conjugate if it's going to get you to a Pythagorean identity that you can use to help simplify things. So again, these are going to be a little bit challenging at first. They will take practice. They are using a lot of different skills, Algebra 1 skills, as well as simplifying fraction skills, and then also knowing those identities, the reciprocal, the quotient, the Pythagorean. Also be able to rearrange those Pythagorean identities to use them in a substitution. So that is it for 7.1. And you have 7.1 WebAssign homework.